So this video is continuing on from the previous, where we solved this differential equation for this equation here of x equals. So now what we want to do is this extra part, which tells us that if the position of the object is x equals 1 meter, when t is equal to 2 seconds, we need to find where the object is after 3 seconds. So the first step here is going to be using this condition that we've been given in order to solve for c. So if we know x and we know t, c should end up being the only unknown in that equation and possible to solve. The second step then is once we know c, we should be able to find where the object is, which is the x value here, when t is equal to 3 seconds. So let's start off by using this condition. So we've got x equals 1, t equals 2 that we need to substitute in here. Alright, so going ahead with that, we're going to get 1 equals negative 1 over. Anytime we see a t, it's getting replaced with 2. And we have our plus c on the end. So now what we need to do is rearrange this equation to get c on its own. So I might clean up the bottom line here. So we've got 2 squared, which is 4, divided by 2. So that's going to leave us with 2. And then 2 times 2 is 4. So we can clean this up even further. So 5 times, well, let's just do it in one step. 5 times this is negative 2 is going to leave us with negative 10 plus the c. I'm now going to move this up to the top line of our equation on the other side. So that's going to become 1 times this, so negative 10 plus c. And we just still have the negative 1 on the right hand side. And we want c on its own. So all we need to do is shift the 10 to the other side of the equation. So it's going to become positive when that happens. So overall that leaves us with c is equal to 9. So now that we know that, we should go back and rewrite it into our solution to the differential equation. I'll pop it here. So the solution now is that we have c is equal to 9. So plus 9 on the end here. Alright, so now we should be able to attempt the second part, which is finding where the object is after 3 seconds. So all we need to do is set t to be equal to 3 in our equation. So x equals, any time we see a t, we're changing it to 3. Alright, so now we just need to clean this up. So we've got 3 squared divided by 2, so that's 9 divided by 2, or 4.5. And then 2 times 3 is 6. Next I might simplify this, so we're going to get 5 outside of 4.5 minus 6. That's negative 1.5, plus the 9 on the end. So if we do 5 times negative 1.5, this takes us to negative 7.5. And then this overall is just going to leave us with 1.5. So the last little bit, it might be worth changing this into a fraction. I think it makes it easier in my head at least. So we can write 1.5 as 3 on 2. And then we want to divide by this 3 on 2. So you can write it like this. And remember that dividing by 3 on 2 is the same as multiplying by the reciprocal, which just means you flip the fraction over, so it becomes 2 over 3. So that means that all we're left with is negative 1 times 2 on 3, which is the same as negative 2 over 3. So that's the position of our object after 3 seconds. Remember that it was measured, I think it was in meters, relative to some point of reference. So as our final answer, it should have the unit on it. So the position after 3 seconds is negative 2 over 3 meters relative to whatever that point of reference actually was. So that's the answer to this question, and see you in another video.